This Excel report started as 3 messy monthly CSV files. The source data contained a duplicate order, an invalid date, inconsistent region names, and one negative amount. Python loaded the files, checked the problems, cleaned the valid rows, calculated the business metrics, created the charts, and exported this finished workbook. By the end of this course, you will build this complete workflow yourself. You will be able to place new files in an input folder, run one Python command, and receive a checked report that another person can open in Excel. This is a beginner course in Python for data analysis and practical business automation. It is designed for people who already understand rows, columns, formulas, filters, or pivot tables, but have little or no programming experience. If you can understand that price multiplied by quantity gives revenue, you already understand the business idea behind our first Python calculation. We will translate familiar spreadsheet thinking into small, readable scripts, and then connect those scripts into one reusable reporting project. You do not need to memorize Python syntax before you begin. You do not need a computer science degree, a paid cloud service, or a company database. We will use local, synthetic files and explain each new idea when the project needs it. The goal is not to replace every spreadsheet. The goal is to make repeated, traceable data work easier to run, inspect, and verify. Our fictional business receives one sales file every month. It also keeps a customer workbook and a table of sales targets. These are ordinary CSV and Excel files, so the workflow resembles the files many teams already use. The raw folder is our source of record. We never silently overwrite these files. The processed folder holds clean data and a data quality report. The reports folder holds charts and the final Excel workbook. Inside the source folder, each script has one main responsibility. Load_data.py finds and imports the files. Clean_data.py standardizes the values and records quality issues. Analyze_data.py calculates metrics and summary tables. Create_report.py creates the charts and workbook. Run_pipeline.py connects the steps so we can run the workflow from one place. We will not build all of this today. This lesson gives you the map. Every later lesson adds a small, understandable part until this structure is no longer a mysterious finished project, it is your project. At the project root, we run one command, python src/run_pipeline.py. Python means use the Python interpreter. The file path tells Python which script to run. The script finds 3 monthly sales files and loads 120 raw rows. It removes 3 exact duplicates, quarantines 1 invalid row instead of hiding it, and keeps 116 valid rows for analysis. The validation result is pass. The total revenue is $48,275.50, and the report is written to the reports folder. Notice that the workflow creates more than a polished workbook. It also preserves the clean data and a quality report. That makes the final number easier to trace. We can compare the revenue printed in the terminal with the value in Excel, and both must equal $48,275.50. A useful automation does not merely run without an error message. It produces the expected files, exposes rejected data, and lets us verify important values. Now let us look at the most important failure in the course. One source row contains an impossible date and a negative value. If we ignore that row, our totals may be wrong. If we silently delete it, nobody knows that the source file had a problem. This time, the pipeline fails on purpose. It writes the critical issue to the data quality report and does not create a new Excel report. The message tells us what happened and what to do next. In the quality report, we can trace the problem to the source row, the field, the invalid value, and the validation rule. In a real workflow, the responsible person would confirm the correction with the source owner. For this synthetic course fixture, we switch to the documented corrected input and run the same command again. The corrected fixture still contains the documented teaching row course Q0001. Policy allows that one known row to be quarantined while the quality result remains pass. Any undocumented invalid row is critical and stops the report. Now validation passes, and the report is created. This is a better result than producing a beautiful spreadsheet from untrusted data. Automation should make problems visible before they become business conclusions. Here is how we will build the project. First, we cover the minimum Python foundations for data work. You will install Python and VS Code, run a script, and use variables, lists, conditions, loops, and functions with sales examples. Second, we learn reliable file handling. You will work with paths, read CSV and Excel files, combine monthly files, and create a predictable folder structure. Third, we learn Pandas. A Pandas data frame is the table-like object we will use to inspect, select, filter, transform, group, merge, and summarize our data. Fourth, we clean messy data. We will make missing values, duplicates, inconsistent text, invalid dates, and invalid numbers visible. Then we will apply explicit rules and save an audit result. Fifth, we answer business questions. We will calculate revenue, profit, average order value, monthly trends, top products, top customers, and performance against targets. Sixth, we turn the analysis into communication. You will create readable charts, export multiple tables to one workbook, and format an Excel report automatically. Seventh, we make the workflow repeatable. We will separate configuration, add logging and validation, schedule a script, and prepare a report email without sending anything unexpectedly. Those 7 stages complete the core business reporting project. After that, optional modules introduce responsible API and web data collection, followed by a narrowly scoped AI-assisted summary. The calculations and validation remain deterministic. Any generated summary stays clearly labeled and requires human review. You can follow the full course in order. If you already know basic Python, you can use the lesson titles and prerequisites to join at the right point. The first 12 published videos also form a practical mini-course: setup, loading data, Pandas basics, cleaning, combining files, and a finished Excel report. We will use 4 main tools. Python is the language and runtime for the scripts. Pandas handles table-shaped data. Matplotlib creates the charts. OpenPyXL helps format the final Excel workbook. You do not need to learn each library in isolation before doing useful work. We will introduce a feature when it solves a visible project problem. Every practical lesson follows the same loop: inspect the input, make one focused change, run the code, and verify the result. We will inspect row counts, data types, terminal output, written files, and selected expected values. When something fails, we will read the error and fix the cause rather than hide it. We also keep raw inputs separate from processed outputs. This simple rule makes practice safer and debugging much easier. If a transformation goes wrong, we still have the original synthetic fixture and can reproduce the problem. Let us recap. The final project starts with monthly CSV files, customer data, and targets. Python loads and validates those inputs. Pandas cleans and analyzes the valid rows. Matplotlib creates charts. OpenPyXL helps export a formatted workbook. The pipeline also writes clean data and a quality report so the result can be checked. Your assignment is simple. Create a folder named Python_data_analysis. Inside it, create 4 empty folders: data, reports, SRC, and tests. Then add a plain text readme.md file and write one sentence describing a report you would like to automate. Do not use private or company data. A fictional sales, inventory, expense, or support dataset is enough. You are done when you can point to the input folder, the future output folder, the code folder, and your one-sentence project goal. No Python code is required for this assignment. In the next lesson, we will install Python and Visual Studio Code, verify both installations from the terminal, and prepare a clean environment for the first script. After that, we will translate a familiar spreadsheet formula into working Python code.